Hello! I'm sorry that I'm not yesterday I don't put a video, but today I put it. This week I will not put very much video because I have study and school and like this. So I'm sorry if I late, but inshallah I will benefit or enjoy in today's lesson, and it will be very good lesson. Grade 7 subject physics page 2930. The date is 21/12/2021. Chapter 7, the gas laws. The learning objective of this lesson is gases, characteristics of gases, Boyle's law. I will speak now about the gas laws. I can read it, and after that please you can read it alone to note and understand it, okay? When investigating the behavior of gases, we must consider three varying quantities. You can see these are the three. This is that's three varying quantities. Pressure, volume, and temperature. This is pressure and volume and temperature. These are the three things. These are the consider three varying quantities. 1, 2, 3. Okay, and we will speak about it more here in the lesson. In the following experiment, always keep one variable constant and investigate to the color of two variables. Experiment 7.1. Keeping the temperature constant. This is a Boyle's law. Use the apparatus in the diagram to investigate how the volume of air depends on the pressure applied with temperature kept constant. Use the vertical scale to find the volume of trapped. You know the vertical, this is the vertical scale. This is the vertical scale, you can see it. This is okay, this is the vertical scale and the volume scale. I'm here, okay. And what is the volume of air in the diagram? What is the volume of air in the diagram? Please answer this question in the description. Any question I will put in listen, please see it in description or write the question to I will give you a like. And the last one is, what is the volume of air in your apparatus? Okay, the pressure on the trapped air is measured using a Bourdon pressure gauge as shown here. As you can see it in the diagram here, this is the diagram. Okay, see it. Okay, what is the pressure on the gauge in the diagram? Where is the pressure gauge in this diagram? And what is the pressure in your apparatus? Why is the pressure not 0? See page 18. Now use the pump to exert more pressure and squeeze the air. This will make trapped air slightly warmer, so wait a minute to let it cool back to room temperature. Now measure the new pressure and volume and put your result in table. Use the pump again to get more results. Here I have some possible results. Pressure B and volume V and B multiplied V. Okay, this is an possible result, and let us complete our reading. The calculate PV pressure multiply volume for each of result. What do you notice? This is called Boyle's law. You know now what is I'm saying? If you calculate pressure multiply volume for each set of results, this is what we call it Boyle's law. After it is discovered, Robert Boyle, someone named Robert Boyle, who discovered this thing. For fixed mass of gas at a constant temperature, PV equal constant, or P1 multiply V1 equal P2 multiply V2. Do you notice that if P is doubled, V is halved? If B increases to 3 times as much, V decreases to 1/3. This means volume is inversely proportional to pressure, or V1/P. See example 1 in page 33. The example 1 is a deep sea. This is an example. Deep sea diver is working at depth where the pressure is 3.0 atmospheres. He is breathing out air bubbles. The volume of each bubble is 2 centimeters. At the surface of pressure is 1.20 atmosphere. What is the volume for each bubble when it reaches the surface? Please answer this question. I read it. If you want to read it again, I will read it again. A deep sea diver is working at a depth where the temperature is 3.0 atmosphere. He is breathing out air bubbles. The volume of each bubble is 2 centimeters. At the surface pressure is 1.0 atmosphere. What is the volume of each bubble when it reaches the surface? Okay. Let us go to another page. Here we have gases. Gases is variable volume and shape. Expand to a copy volume available. 3. Volume, pressure, temperature, and the number of moles present are interrelated. 4. Can be easily compressed. 5. Exert pressure on whatever surrounds them. 6. Easily diffuse into one another. This is gases. The gas law. Learning all, I will be able to describe Boyle's, Charles, and Gay-Lussac laws relating T, B, and or V, and be able to calculate unknown values using the equation derived from these laws, as well as the combined gas law. Here, 1. Intro of 2 Boyle laws. Imagine that you hold the tip of syringe and the tip of your finger so no gas can escape. Now push down on the plunger of syringe. What happens to volume in the syringe? What happens to the pressure the gas is exerting in the syringe? Decreases volume, increases collision, and increases pressure. Here we have a photo. Can see it and believe what's happening here. Say it to me. Say it to me in the description what happened here, okay? So you can enjoy with me or answer this all. Boyle's law. This is what I'm saying about Robert Boyle. This is Robert Boyle. You can see it here. This man, 1. He made the pressure and the volume of gas are inversely proportional. As one increases, the other decreases, and vice versa, at constant mass and temp. Here you can see B and V, like this. This is the diagram of Boyle's law plot. V with P. Okay? And Boyle's law leads to the mathematical expression assuming temp is constant to B1 V1 equal B2 V2, where P1 is represented in the initial pressure, V1 represented in the initial volume, and V2 represented the final pressure, V2 represented the final volume. And thank you for watching our today's lesson. I hope you enjoy by this lesson. Goodbye. See you inshallah after today's, or I will take a photo and the next week, in the next week or today, or I will make today and I will put it tomorrow. I don't know because I have school. And so see you after how many days. Goodbye.